So over the last few years in psychology and other social sciences have been a lot of crises. So mainly one crisis, one most well-known crisis, the replicability crisis. Oh, that this word. But there has been talk about a lot of other possible crises. And one of them, importantly, has been the so-called and another one has been the so-called theory crisis. So the idea that basically psychology has been building a lot of facts or replicable or effects in general. So experiments, producing a lot of ideas, but there has been a lack of integration. So it means mainly the idea that we have a lot of disconnected results which do not integrate into a general theory of human behavior. And this has been called a theory crisis as well. And the idea that even if we make progress on replicability, then we won't have a general vision of human nature or human psychology. And so we have these two crises, and the basic question is basically, how are they related? Is one more fundamental than the other? Is one producing the other? Are they interdependent? Are they completely independent in general? And if you followed debates in meta science over the last few years, you may have seen that there are a fairly large number of psychologists, among them, so really famous psychologists like Joe Henrich, Michael Muthukrishna, Daniel Navarro, Bernard Devezer, etc., have been proposing that there is actually a very strong link between the two, and it's the theory crisis that is most important. And basically, it's the lack of theory that is causing the replicability crisis. And so today, I'm going to present the arguments in favor of this idea, in favor that these people have been putting forward in favor of the dominance of the theory crisis over the reproducibility crisis. And I'm going to propose an alternative vision of the relationship between the two, which is basically that there is some interdependence, but it goes both ways. So lack of theory is fueling replicability crisis, but lack of replicability is also fueling the theory crisis. And the link is fairly weak. So on the one hand, here you have huge arrow, so it's really clearly one main cause. But basically, the two are still fairly independent. You can have very strong theory building without replicability, and you can have replicability without strong theory building. Okay, so before I get on to main arguments, what do I mean by theory? By theory, I just mean something like a general map of certain entities that are causally linked, and with assumptions about where the causal links are going. So it's basically ontology, so assumptions about some things that exist. So it may be, okay, there are bodies with a certain mass, for instance, and if there are two bodies with a certain mass in proximity, they attract each other. So here in physics, you have both ontology and causality in a way. And in psychology, it may be, so people have desires, beliefs, etc., and they are causing their behavior. So this is what I mean in general. And why should this be the foundation for replicability? Why should this be the most important thing to work on? So there have been three main arguments against focusing on replicability based on theory building. So the first argument that has been put forward is the idea that basically experiments without theory are meaningless. So it's an argument about the interpretability of replicable results without theory. So you just don't know what you get if you are doing replicable experiments, but you don't have a strong theory to back your experiment. So one argument about interpretability. A second argument is about the value of reproducibility without theory. According to the second argument, there is just no value in replicable experiments that are not backed by a strong theory. And then the third argument is about practical action. So about practical action, this means that even if you really wanted to focus on replicability, then directly trying to improve the replicability of your experiments would be a bad idea. According to the third argument, theory is a means towards replicability. So I'm going to present each of them a bit more detail now. So the interpretability argument is basically summarized by the idea that all interpretation of data is necessarily theory laden. So what does this mean? It basically means that if you are doing an experiment and get some data, then you have to have theoretical assumptions that allow you to interpret your results. So for instance, let's say you are trying to measure social class. This is a very standard way to measure social class, the MacArthur social class scale. So people, you are asked to imagine that this is the ladder for social success. On top are the the richest, most powerful, etc. The bottom, the least reached, least powerful. And people are asked to put themselves on one ladder of this scale. And so this is interpreted as one measure of social class. But quite clearly, there is no obvious conclusion between how people respond to this scale and where they are on real social class. Like there are a lot of assumptions baked into both psychological assumptions about how people would react and what is social class and what this, how we can map the two. And so without strong theoretical assumptions, it's hard to know exactly how we can interpret someone putting themselves on top of the ladder, on the middle of the ladder, or on the bottom of the ladder. And so according to these proponents of theoretical priority, you have to have strong theory before you can summarize an experiment. So for instance, let's say you have the result that people with a higher social class are more antisocial. So this has been shown with these kind of measures. But it's hard to know exactly whether this is the true meaning of an experiment, this experimental result. So this could just be, if we were to be more precise, we would have to say, so people who rated themselves higher on the MacArthur scale gave them less money in a further dictator game with these specific instructions. And so if you were to be faithful to your experiment, you would have to include an incredibly long description of the experiment, and you couldn't just make any clear conclusion. And so basically, you have to have some theory to interpret your experiments. Okay, so that was the interpretability argument. And the second argument is the value argument. So basically, replicability without theory has little or no value. And it's based on two sub-arguments. So one is the interpretability argument. So if the experiments are meaningless, then you just can't have any value in them. And the second argument is based on the low value of disconnected facts. So if you just have a lot of experimental results published in billions of psychological papers, then nobody's going to read them. Nobody's going to understand them. Nobody's going to integrate them. And so it's the same thing as just throwing all your experimental results in the sea. Because if there is no integration, then we just don't have any kind of format. So I'm going to go further about that. The third argument is what I call the theory as a means argument. If you have a better name for it, I'll take it. It's just the idea that theory is both the ultimate goal of science and the means towards replicability. And so these people are really thinking that even if we wanted to improve replicability, directly trying to improve replicability via pre-registration would be a bad idea, because we would be better off starting to build strong theories that will then ultimately lead to better replicability. And so they have put forward a few arguments in favor of theory helping replicability. First, theories help identify contradictions between fields. So this is very clear in some fields. For instance, if you have an experimental result showing that neutrinos travel faster than light, then you have a strong theory, relativity theory, saying that this is impossible. And so people are going to want to replicate this effect and are going to show that it's wrong. So that's what happened in physics 10 years ago. And so what we have here is that if we have only disconnected facts with no coherence between them, then if there is one new result then published, we don't know whether these results should be seen as surprising or as worth replicating. But if we have strong theories, then we know what should be the expected results. And then anomalous results should be seen as problematic and should be replicated and rooted out. So first, theories can help identify low plausibility results and help root them out. Second, theories help determine the boundaries of effects. So if you have strong theories, then you are going to know when an experimental effect is going to be strengthened or weakened, etc. And this is going to help you replicate it. And third one, which is a more sociological version of the first argument. So strong theories help create a community of researchers. And if you have a strong, united community, then people are going to build on other experimentals or their experimental results. And so this idea of building up on the results of other researchers means that people are going to check one another. And so according to these authors, fundamentally, psychologists have just too disconnected. And we just don't care enough about the results of other researchers. And so if you don't care about the results of other researchers in your field, you are not going to try to replicate them. But if we had a strong, united community, then we could have a community building up on more results. And in general, I'm not going to argue really against these ideas. I think they are pretty interesting and reasonable. So in general, I think they are pretty strong. All the arguments that I've presented so far are really interesting and pretty strong arguments. But I'm just going to be pure pluralist. I'm just going to argue that, yes, there are good reasons to think that stronger theories are going to help for replicability. But this does not mean that replicability is meaningless, worthless, and almost impossible. We can do both, and replicability is going to be a means towards theory building. Okay, so each argument kind of refuted, or at least examined. The interpretability argument. So it is clear that replicability does not guarantee validity. So if you use the MacArthur scale for social class, then it's going to be a very strongly replicable result that people higher on the scale are going to be less pro-social. So this is a true result, but other measures give other answers. So even this specific replicable results does not guarantee validity. But I don't think that it's true that theories are necessary for identifying effects. And I think psychologists have still been pretty good at finding some kind of general effects. For instance, let's say smokers are less likely to believe that smoking is dangerous. So this is not based on some kind of high-level theory. Of course, you can justify it by some kinds of confirmation bias or stuff like that. But it is still very low-level idea. And this is pretty replicable results with different operationalizations. And in general, there are a lot of ideas in psychology. So for instance, my side bias, which are general phenomena and that psychologists have identified. And I think there are just hundreds of such results that psychologists have been able to identify without any kind of high-level theory. So what's going on here? On the one hand, it does seem that a lot of assumptions or theoretical assumptions are needed for interpreting arguments. But on the other hand, it does not seem completely necessary. I think a lot of the debate here has been going on because there are different levels of theorizing. And what is utterly necessary for interpreting any experiment is basically having naive assumptions, having some assumptions about the world. So let's remember the definition I used of theory. So basically, ontology, some assumptions about how the work is, the entities in the world, and causality, so in assumptions about how these entities are related and interact. And we all have, everybody in this room, pretty amazing theories, naive theories about how human beings behave, about beliefs, desires, about self-interest, etc. And so all this naive psychology is utterly necessary to interpret any psychological experiment. This is not some kind of high-level theorizing. In a way, it's a high-level theorizing, but it's produced by evolution and just already ingrained. And then there are different levels of theoretical sophistication that we can develop. So it can be assumptions honed by researchers' experience. It can be explicit assumptions. So we can have an explicit verbal theory. And so the first one, naive assumptions, so our folk theory of psychology, everybody has it, but we can't necessarily explain it. But then we can put it through research, through theorizing explicitly. And then another level of sophistication would be an explicit mathematical models of how people behave. And what is interesting here is that when proponents of theory building are saying that strong theory is necessary to interpret experiments, they are meaning that the last one. So explicit mathematical models are necessary to interpret psychological experiments. But most of the time, I think naive assumptions are already good enough to interpret the results of assumptions. And I'm not saying that naive assumptions are enough. Of course, it's better to have more sophisticated, verbal, explicit arguments about our theories and to develop mathematical models. But it's just replicable experiments are not meaningless without strong theory. We already have a lot of psychological knowledge and naive psychological knowledge, and we can build from that. Okay, so this was the interpretability argument. So next, the value argument. Here again, I'm going to grant a lot of power to the arguments put forward by the proponents of theory building. So there has been a lot of debates in philosophy of science about the sources of scientific value. So what constitutes scientific progress? And among the major debates, so two big theories lately have been proposed. So the growth of scientific progress is caused by the growth in knowledge, so more or less justified through belief, versus understanding. And so understanding, the idea that we progress in science when we grow in terms of understanding, is chiming pretty well with the theory, the proponents of theory. And just going to say why we should focus in the long run in terms of progressing in terms of understanding. So theory is a map of causal relationships between entities. And that's incredibly important, actually. Understanding good theories has a lot of power and a lot of value in science, and maybe is the highest source of value, but it's just not the only one. So what makes good theories? So good theories tend to have a wide scope and be accurate. So these are theoretical virtues. And I think it's true, as the theory proponents assume, that the highest source of value is understanding accurate theories with the widest scope. So what is going on here? So for instance, Newtonian physics, it's pretty accurate. You can predict incredibly well the movement of stars, etc. And it has the widest scope. It applies both to stars and everything on Earth. And if I let this fall, this is going to fall, and we can predict how quickly it's going to fall. And it's completely amazing. And developing these kind of high-level theories is going to be a major source of value in science. And so we can put forward a lot of different arguments in favor of this value of high-level theory. One major argument is that understanding theories allow us to have robust knowledge. So it's not only that we understand this particular specific experiment with this particular operationalization, but we can also understand what is going to happen if we slightly change the results. So for instance, let's take nudges. We don't have a good theory of nudges. And so what social psychologists have been doing for the last 10 years has been doing new nudges in different contexts. And some of them are replicable, some of them are not. But we have just not accumulated a robust knowledge of what would happen if we use a slightly different nudge in a slightly different context. But if we had good wide scope theories, then we could have robust knowledge. We could know what would happen if we slightly modified our experiments. And this leads to applicability. So if you have the robust knowledge applicable across a wide range of domains, then you can change the world. And a third value of understanding theories that it tends to be simpler. So what do I mean by simple? It's just you have to understand one theory and then you can understand the world. You don't need to read every engineering experiment since Newton. You just have to understand Newtonian theory. And then it's basically a few pages and then you can already predict a lot of things about the world. But in psychology, you have to read each and every psychology article published over the last 100 years. And there is no single way of summarizing all these results. So all this means that, yeah, I think it's true that theories are the highest source of value in science. But it just doesn't mean that knowing some basic facts has absolutely no value. I think basic facts have some kind of interesting value. I think it's somewhat valuable, for instance, to know that smokers consider that smoking is less dangerous. In history as a field has been the accumulation of knowledge about specific events. And I think it's interesting to know how the French Revolution started. And I think it's valuable to just have this accumulation of knowledge. It's not enough. It would be better if we had integrated theories, but just saying that it has absolutely no value is, I think, slightly nonsense. Second, in some cases, basic facts can still be applicable. So for instance, developmental economics have been doing a lot of experiments without any kind of theorizing or very weak theorizing over the last few years. And I still think it's incredibly valuable in terms of applicability. And third, and that's what I'm going to focus on during the last 5 minutes, knowing basic facts, having an accumulation of reproducible results can be seen as a means towards theory building. So it has both intrinsic value and can be seen as a means towards building theories in the long run. So back to the third argument. So some theory proponents have argued that even if we wanted to promote reproducibility, we should focus first on building strong theories, because theories are helping to identify contradiction between effects, etc. So this means that, generally speaking, we could expect that if we had strong theories, then it would help replicability. But at the same time, we have to acknowledge that this is not enough. That in general, even with strong theories, you can't expect strong replicability. One basic reason for that is just the curse of motivated reasoning. If you don't have any theory, then why should you p-hack? When should you try to do some kind of publication bias? Well, you have already one motivation. Publishing surprising results is always a motivation for p-hacking because it's more interesting. But if you have theoretical predictions about what your results should be, then you actually have a second motivation for p-hacking. You may want your theory to be true, and you have some additional motivation to fall in line with what your theory expects. And this is one argument in favor of strong theorizing not being enough for building reproducibility. Another argument is that even in fields with strongish theories, we have seen a lot of causes of concerns for replicability. So the first one it's not that strong a theory, but evolutionary psychology has had, I think, a pretty bad track record in terms of replicability. And we can debate whether this is a strong theory, but in general, people in this field are doing more math and most mathematical models and are trying to think harder about how to build strong theory. And it doesn't seem to be leading the way in terms of replicability in general. But to take a less controversial example, applied physics is an interesting field because we don't have a lot of data on that, but it seems that engineering or material science is facing a lot of reproducibility issues. And we still don't have large-scale experimental results on that. But there is one classic paper by Fanelli about publication of positive results by field. And in this paper, Fanelli is basically showing that among applied fields, you always have the same kind of proportion of positive results. So it's about over 90%, both in physics and in social psychology, for instance. And so this idea is that this should be a cause of concern. Maybe these are true positives, but I doubt it. And in general, even in fields where you have strong theories backing your results, you still want to produce surprising or interesting results. And this is still an incentive towards irreproducibility. So even if in fields with incredibly strong theories, there is still a replicability crisis, this is not going well. Okay. And another argument against seeing theory as the priority thing to do is that, okay, good theory may help reproducibility, but it's also true the other way around. Reproducibility can be seen as a means towards theory building. The most important argument for that is simply that good replicability is a strong desirable feature in terms of measurement. It's basically a measurement issue. If you don't have replicable results, then you are just adding another source of noise and bias above and beyond everything that is already polluting our experiments, like lack of measurement and lack of validity. And so measurement, it's completely uncontroversial that measurement is utterly necessary for strong theorizing through two principal means. First, exploration. So if you have careful, precise measurements, then you can examine your results and then start to make hypotheses about what could be generating these measurements. So exploration and then testing. So without strong testing, you don't know exactly what without strong measurement, you don't know exactly what are the predictions of your theory. And so you don't know exactly, you can't test severely your experimental results. So this is the major argument in favor of defending the incredible importance of replicability in favor of theory building. Another argument, which is slightly weaker, but I think both replicability and theory building require, to some extent, similar skills, like at least having some understanding of mathematics, formal building, and simulations are going to be incredibly helpful both for promoting replicability in the long run and theory building. And the third one, which I will focus on the last 2 minutes. How am I going on time?
You have like 1 2 minutes.
Okay, that's good. I think replicability can shatter an illusion of progress. And I think that's what has been going on in the last few years. And that's what can contribute to theory building in the long run. So in the 2000s, we had a golden age of social psychology with growth mindset, with ego depletion, with a lot of different high-profile theories. And these led to a feeling that social psychology was doing well. And if these results were true, then social psychology would have been going incredibly well. But now we know that this was just an illusion. And the results that are left tend to be fairly boring, I think. We have just kind of a dilemma. Either we have completely imaginary, irreproducible findings, or we have perfectly replicable but perfectly boring findings because we already knew them all. And I think theory building can be a way out of the dilemma. For the next few years, I hope we will get more boring and more boring. And maybe at some point, we are trying to build some strong theories that are going to be incredibly surprising, but for the good reasons. Okay, so in conclusion, I just think theory building and reproducibility are complementary, and that we should build the two in the long run, and that progressing the two are going together. And in general, I'm a pluralist. I think both are important. So this is kind of me conclusion, but I think it's the most important thing to focus on right now. Thanks a lot for your attention.